synthesis, characterization, and applications of environmentally friendly sizes to cotton wool. This is a collaboration research between NC State University and National Research Center of Egypt. And we have two teams that have different disciplines. The team from National Research Center got the expertise in chemistry, cellulose, and starch, which allowed us to prepare new sizes. And Dr. Mohamed and myself were at NC State University working on how to apply these new sizes to cotton balls. I will start the presentation. Sorry for, it's my mistake, I just got the cable out. Blame it on me. Like I said, this is a collaboration research between Egypt and North Carolina State University, and it is funded by the National Research Center, with Academy of Research. What do you call it? Academy of Scientific Research and Technology. We covered the United States by the National Science Foundation, NSF. And Dr. Mohamed is here today. He is one of the authors. Please raise your hand, Dr. Mohamed, so everyone will see you. And you ask me the easy question, you ask him the difficult questions. We are basically National Science Foundation of the US and Academy of Statistics from Egypt for the funding of our I would like to speed up. We all know roughly what sizing is. Sizing is done to make the weaving performance as high as possible. You need high efficiency. You have to size your cotton, especially single cotton. The traditional sizing have drawbacks. It takes considerable time to prepare, to cook. You have to have a cooking room. You have to do resizing by chemicals or enzymes. And this is, in short, unfriendly process if you follow the traditional way of doing it. Our main goal is to develop environmentally friendly sizing agents that you can use for cotton molds, which is interesting to Egypt. Egypt is using a lot of cotton, as well as US using a lot of cotton too. So NRC was developing the sizes, and we, Dr. Mohamed and myself, supervise students to apply these sizes, use these sizes, and apply it to cotton molds. We have here two approaches. One here is one is to develop an expensive starch-based sizing material. And we have recoverable sizes developed, and also what we call the active sizes. So recoverable sizes you can recover after you resize and take it back and use the again. So it's in the environment. The other size is reactive, that will stay with the cotton, stays after weaving. You don't have to resize it, and you can use it as dual functions. One is to make the weaving performance high, and the other one is to keep it as finishing agent. Those are the two approaches, but the goal is the same: protect the environment from the waste. Okay? That's what I mean. We spun 4 cotton yards, single, with the same twist model at NC State University. And we use 7 different sizes. 2 commercial sizes, and 2 experimental active sizes. And the idea you see there is what we're going to communicate with during the remainder of the looks like one machine, but it has a small size box where you can put a size solution there and apply it to the yarn. And we use different speeds, 2 speeds, so we can control the percent solid or the percent add-on on the yarn. And we calculate the drying time from the length of the yarn we decide to dry. And the drying time was calculated also from the speed and the length of the yarn we decide to dry machine. And these are the parameters as far as yarn speed, yarn length in the drying section, and drying time. And you can see every size material is treated with 2 different speeds. This is a percent solid that we had in the size box for each one, and this was optimized. We tried higher percent solid for number 3, for example. It didn't work. This was the minimum that we could have done. Otherwise, we have very thick, very high viscosity solution put it here on the side of the yarn. So we had to drop down to 9.5, and for number 5, we had to drop it to 6 minimum that you can use. We evaluated the yarn using the Ozkurt jet. This is high-speed tensile tester, and this simulates the weaving process. And in weaving, you will get the yarn at very high speed. So this is simulation of what's happening during weaving. We use the Ozkurt 3 to measure errors and resist mid counts, and we use yarn with friction and also abrasion testing. Here are the results. I have to be faster. I'm showing you the low speed and the high speed for each yarn and for each property. This is a breaking load, the strength of the yarn. And you can see on the very right, you see the untreated yarn. And from the left, you have 1 through 7. So we have 8 columns there representing the 2. The first 2 are, remember, the conventional ones. Number 3 and number 4 are the reactive sizes, and the last 3 for the left are the retrievable sizes. So you can see that all outperformed the unsized. We have improved the strength for all, and we are much better probably than the conventional. And you can see this in all the yarns. For 10, some yarns showed a little bit about the same, like 20, about the same, and some are higher. Mostly all of them, but 1 higher. Alright. So we have some variation between yarns, but in general you can say that the strength of the commercial sizes and the experimental sizes are about the same, and all better than the, as far as strength, better than the unsized. If we go to hardness, we are very successful. We have less hardness than untreated. And this is what you need to do in sizing. You need to hide or cover the hairs of the yarns. And it is really 50% as compared to all the sizes as compared to the untreated. And you can see this with all the yarns. Low speed or high speed. Coming down to another property, which is friction. The friction here is high. Even the commercial, if you look at the commercial number 2 is PVC, right? And it's sticky, it was very sticky. This is not coefficient of friction, in fact, this is the stickiness of the yarn to the roller where the friction is measured. And this is just like bearing force for getting the yarn out of stickiness. So we have very high coefficient of friction. So we can see some, if you look at number 7 has the lowest coefficient of friction. Why we don't have a good coefficient of friction? Because we did not have any lubricant in the formula. We decided not to put any lubricant, not to interfere with the action of the active sizes. And to make a good comparison between all the yarns, we decided not to go for all. good lubricant, it will be much better. Despite that, if you look at number 7, it's always having less coefficient of friction than the untreated. And you can see this all along. We started now looking at abrasion resistance. Abrasion resistance also depends on the lubricant. And despite that, if we put some lubricant, we could really improve the abrasion tremendously or significantly. And you can see number 7 again is going to be consistently lower than the untreated, despite there's no lubricant. We have, in some cases, we have higher abrasion resistance. So you can see we have mixed results, but we know that we didn't add lubricant. We know the reason behind why we have low abrasion resistance represented by the number of cycles. We looked at residual starch test. Why we did this? Because we would like to see if the reactive sizes stayed after boiling they are or removed. So our purpose is to have reactive sizes that stay where they are or stay with the fabric after resizing or after finishing. We don't decide. And also to evaluate the reclaimable sizes. If this is truly reclaimable, easy to reclaim, we should see no starch after boiling the fabric. So we've done some samples, we've some samples. We put the yarn in the filling direction, doesn't matter. It is only to test the removability or the fixation of sizes. So we put it on the filling yarn for easy weaving, so we can weave it quickly. And here is how we tested the boiling. It's 30 minutes. The time is not shown here, but 30 minutes in a boiled water. And we have 20 to 1 liquor ratio. Then we done the so famous, so known iodine test, iodine test, and here are the results. For size 1 and 2, these are reclaimable sizes commercial. We did not buy the starch. This means these are reclaimable and they are good enough. For size 3 and 4, these are reactive sizes and we're supposed to find starch. As expected, we found starch. For number 5, we did not expect to see starch. We were supposed to remove it, it didn't go away by simple boiling. So size number 5 cannot be reclaimed as easy as we thought. Number 6 and 7, as expected, as we hoped, we succeeded to reclaim it quickly. So we have some success. The only problem with the iodine test is it's subjective. You drop a boiled iodine and you see the color. And you judge the color. If the color is too deep, you say positive, positive. If it is lighter, you say positive. And it's going to be different from person to person, judging the color depth. So we feel that we need to do some other tests, subjective tests later. I'd like to conclude here by saying that I think we have developed some promising sizes. But the judge is commercial trial or implant trial. And we plan to do that in the future. We also know that we need more evaluation regarding the abrasion and regarding the coefficient of friction. We need to optimize the size solution recipe by adding some lubricant. And we need to make sure that lubricant will not react or hinder the reaction between the cotton molecules and the size agents. Also, we need to devise or develop a way of objectively evaluating the starch, the amount of starch in the yarn. In fact, this was a preliminary experiment. We are not claiming this is a good experiment. We ran this by undergrad students. After that, we have done more extensive work. We done some evaluation for better than iodine test. We done some of that, but the paper was not ready at the time that I submitted this. So I decided to submit the preliminary report, and looking forward to probably see you next year to tell you the rest of the story.